In this video, we're going to grab some data. We won't really do a lot with it, but we'll take the opportunity to show off some capabilities of the requests library. So let's get some weather data. Weather is a very common thing, and there are multiple weather APIs we could use. I'm going to just Google around. I know that weather.gov has an API, so I'll click through to it. So if I try to use this URL, you see it has API in it, but I'll run into a problem because we're sitting here on this page and we can see that it doesn't have the data that I want to get. This URL is the root of the API, not a data returning endpoint. And what we need is a specific endpoint. And as the word root suggests, we'll get that by adding to this file path. And this website is very well designed and tells you what the available routes are. A lot of sites don't. And one of my least favorite things is when I find documentation for a publicly available API, but I have to scrabble around looking for the endpoints because they don't include those in the documentation. So if I take this route and add alerts to it, for example, okay, here's JSON. Here is all of the raw data about these weather alerts. This is what I want to access. So before I go to Spider and start doing programming, let's click. I seem to have lost track of myself. Let me end. Here we are. Let me click this authorize button and see what weather.gov has to say. Weather.gov says essentially that they don't require any API keys, that they're planning to in the future, but they don't now. And they require that all consumers include a user agent header in requests, and they have some recommendation about those headers. They recommend that we identify ourselves and include a contact email. So I'll talk more about that when I'm doing the programming. And speaking of, let's get right to it. Okay, so we've got this weather.py script. We're going to use requests. Here is the URL we are going to get data from. And before we do anything else, let's deal with the header that weather.gov requested. So headers are dictionaries in Python, and they can include various information. Like sometimes if a key is required to access data, that is going to be included in the header. For us, they want a user agent, and they want something that identifies us. And they suggested that we provide an email address. So I'll say that this is Math 301 project, and I will share my email address, contact gmoses at csc.edu. And that's the only thing we need in the header for this project. And now let's grab the data. We've got requests, we've got the URL, response equals requests dot get URL. And now if we run this, you see we've defined this header, we've defined this URL, and from the website, we have gotten this models.response thing. Let's see. So this, what I very elegantly called this models dot response thing is hard to do much of anything with. Like if I try to print it, you see we don't get anything useful here. So we need to convert it into something that Python can deal with. And what we have here is actually a JSON. And if we type data equals response.json and then open parentheses, you see now our data is a dictionary. A JSON is a set of key pairs, so it's very naturally converted into a dictionary by Python. And if we print the data, what we'll get is something totally overwhelming, first of all, because we're looking at every weather alert on the planet right now, or at least every weather alert in America. I don't know if it's international. But you see, this data does have all of the weather alert, like if I here, winter weather advisory, freezing rain expected, total ice accumulation around a light glaze. This is in Greenbrier County from midnight to blah, blah, blah. So we have successfully gotten all of the weather alert data. Um, what I'd like to talk about now is all of the requests I've been making. I've been compiling this script a lot. Um, I think like 4 times in the last minute. And every time I've compiled this script, it has pulled data from weather.gov. Every time I've compiled this script, this line has run. And that's bad practice. Our tiny little program is not going to break anything, but you don't want to keep hammering weather.gov servers with requests. And in fact, many APIs will have technical restrictions that will explicitly limit how often we get from them, and would perhaps have raised an error if I'd done this with them. So what should we have done instead? Well, there are a few possibilities. The most straightforward is to save the JSON to a local file and then do all our exploratory steps with that local file. And to do that, we are going to need the JSON library. So I'm not going to go into the details of the syntax here. You can always read the documentation. But once I get this JSON, I am going to save it. And let me see, it doesn't like that. And it doesn't like that, or the fun little troubleshooting that you get to see live in a programming course. This data, where I took response and passed the JSON method, we want to do that, and then we can do this. And now I've run this and I've saved the results of this GET request. And from now on, I can now comment out a bunch of things. In fact, pretty much everything. And I can now load this data. So now that this data file is saved locally, I can just load it. And I can do data exploration responsibly without pounding weather.gov's servers. So if I want to explore data types, for example, I can run this and I can look at data types, and I did not call, where am I? I did not call weather.gov servers in order to do that. A slightly more technical, but much more elegant solution We'll use the requests underscore cache library. So let's uncomment some stuff. Let's just get rid of the saving. And now I'm going to add a line before the URL, or really before the get is the important thing, but I'll put it before the URL. And again, we don't worry about the details of the syntax. The documentation is always there, but here the syntax is pretty straightforward. We have this name, we have a descriptive string, and we have expire underscore after, and this is measured in seconds. So now I'm going to run this. No module named requests cache. Okay, I need to, let's see, Anaconda prompt. Let's go ahead and even share this. Conda install requests cache. And now maybe pause this install because this share, I mean, because it seems to want to ask me a bunch of questions. Hi, this is me popping in again to say that even though in Python it's accessed as requests underscore cache, the name of the thing is actually requests dash cache. So this gave me an error, as you see, and I had to fix that. Okay, so now knock wood. I'll run this and it will not give me an error message. Yep, I ran it and it worked. And what's happening here is this line here is changing how requests.get works. We say that it's monkey patching it. It's modifying its behavior without creating or saving a new method. So now let me once again add these lines into the code. Now, if I run this again, here's what's going to happen. It's going to run this, it's going to monkey patch. And when we get to this line, the behavior is going to change. Now, instead of getting it, Python is going to ask, have I made this same request within the last hour, within the last 3,600 seconds? And if the answer is yes, it's not going to get the URL again. Instead, it's going to get this, which it saved temporarily when I ran this code a few minutes ago. So now I ran it again, but I didn't make a second request because my last request was within an hour. It just used the results of my last request. And that's kind of the basics of API in Python. There's always more that you can say. The big thing we're missing is that we haven't done an example with an API key. So that should be our next video. And I will see you then.